Hi students, today we will go for another important concept in atomic structure, that is nothing but quantum numbers. So now if you observe these quantum numbers, first of all, what are quantum numbers? See, suppose here there is nucleus of an atom and we are having different orbits. For example, if electron is in third orbit. Now, if you want to describe about that electron in detail regarding its position or angular momentum or whatever the important characteristics that we are having for electron. So, to explain those important characteristics, here we have a set of 4 numbers. Those 4 numbers which helps us to explain about the electron in detail, they are what we call as quantum numbers. Now, among them, one by one, we will go for in detail. So, the first one is principal quantum number. Now, what is principal quantum number? If you recollect the postulate in Bohr's model, that is, in a stationary orbit, the angular momentum of an electron is an integral multiple of h by 2 pi, where that integer is nothing but n, and that n is nothing but principal quantum number, which is nothing but number of the orbit. So now here it is k, l, m, n, like that we are having the shells. For them, the corresponding n values 1, 2, 3, 4, like that. So now this n is what we call as principal quantum number. So now if you want to analyze regarding that electron, first of all you should know in which main energy level that electron is present. Now as per the diagram, if you observe that here electron is in third orbit, that means its n value is 3. So it is very clear whatever the electron that we require, that is present in third orbit of that atom. So means we are getting an idea about the main energy level of the electron with the help of this n value. Now based on this, I am coming to the definition for principal quantum number. Means a quantum number which gives an idea about the main energy level of the electron. That is what we call as principal quantum number. So which gives an idea about main energy level or main level of electron in that atom. So that is what we call as principal quantum number. And now one by one, as you know, that was introduced by Niels Bohr and represented by the value, represented by the letter n. Now if we observe the values of those n, means principal quantum number, they are 1, 2, 3, 4 and up to n. So that is nothing but number of the orbit. And here you should remember one thing, for any electron, the value of n should not be equal to 0. This point is very important because there are questions where we have to verify whether the given set of quantum numbers are correct or not. At that point, first remember n should not be equal to 0. It is always greater than 0, like 1, 2, 3, 4, 5, like that. And it should not be as the fraction also, 1.5, 2.5, no chance, because that is number of the orbit. And now, if you observe the importance of this principal quantum number, in Bohr's model we observed to calculate the radius of the orbit, to calculate the energy of the electron, velocity of the electron, angular momentum, number of sublevels. Everywhere we are using this n value. So now here if you observe the importance, means significance of this principal quantum number, we are using to find out the angular momentum of the electron. When we are equal to n into h by 2 pi, already you know that. And similarly, energy of the electron in nth orbit. Similarly, radius of the orbit and velocity of the electron. Similarly, wavelength of the electron in the given orbit. Okay. And already we observed the different relations to find out the number of rotations or time period. There also we are using n value. But mainly angular momentum, energy, radius, velocity, wavelength. Apart from this, here if you observe another significance or the importance of this principal quantum number, since we have the main level and in that there are sub-energy levels. So now number of sublevels in a main level, that is equal to n value. Now if you observe n equal to 1, in that orbit we have only one sublevel, that is nothing but s. N equal to 2 sublevels, that is s and p. And n equal to 3 sublevels, s, p and d. 4, s, p, d, f. So like that. So in a main level, the number of sublevels are equal to its n value. And similarly, number of orbitals in a main level, that is equal to n square. Now once again see here, n equal to 1, number of orbitals, 1 square, only one orbital, that is s orbital. And n equal to 2 square means 4 orbitals, 1 s orbital and 3 p orbitals. So like that, in a main level, the number of orbitals are nothing but n square. And similarly, maximum number of electrons in a main level, that is 2n square. So like that, here we are using the value of principal quantum number n to find out the different characteristics, or that means we are getting maximum information with the help of this n value. So that is regarding principal quantum number. So once again, mainly it gives an idea about the fundamental or the principal energy level of the electron. And after that, the values are like this, and it should not be equal to 0. And this is importance. So now, once again, if we come to the diagram, since we know n equal to 3 for the electron, what we require means that electron is present in third orbit. But in third orbit, again we have sublevels. So, in third orbit, in which sublevel the electron is present? That information we require next. So, for that we have another quantum number, that is azimuthal quantum number. So, now the second important quantum number, which is nothing but azimuthal quantum number. Azimuthal quantum number. Now, mainly it gives an idea about sub-energy level of the electron or sub-level of electron in a main level. Means in that main energy level, in which sublevel that electron is present. And of course, here it was introduced by Sommerfeld and represented by small l. Now, if you observe the values of L, here values of L, they depends on that of N, because it is related to main level. In main level, we have sublevels. So definitely, the value of L that depends upon value of N. And if you observe those values, here the values of L, they are ranging from 0 to up to n minus 1. Means for a given n value, maximum L value is n minus 1. So as for that, suppose if L equal to 0, that is S sublevel, means if electron is present in S sublevel of any orbit, its L value will be 0. Similarly, if L equal to 1, P sublevel, L equal to 2, D sublevel, L equal to 3, F sublevel. So like that here we are using this concept. So anyhow, if you have an idea about L value for the given electron, automatically we are getting an idea in which sublevel of that orbit the electron is present. So that is regarding the value. And now, if you observe the importance, see already you know that it will give us an idea about the sub-energy level. And apart from that, here we can find out orbital angular momentum with the help of n value. That is nothing but root of L into L plus 1 into h by 2 pi. In a main level, mvr equal to n into h by 2 pi. In a sub-level, here angular momentum, that is nothing but root L into L plus 1 into h by 2 pi. So suppose for S electron, L value is 0, so orbital angular momentum is 0. And for P electron, since L equal to 1 here, just we have to substitute the value of L. So like that for D electron, for F electron, we can find out orbital angular momentum. So in this way, the second important quantum number, which is nothing but azimuthal quantum number. Now, once again come to the diagram. Already you know that the electron is present in third orbit. But in third orbit, we have three sublevels, S, P, D. So in which sublevel that electron is present? See, for example, if L equal to 1. So that indicates that electron what we require is present in P sublevel of third orbit. P sublevel of third orbit. Up to that we got the information. But after that, in a sublevel, again we are having different orientations. Means arrangement of the electronic clouds. That is simply what we call as a orientation. And after that, each orientation is considered as one orbital. Okay, so now since electron is present in P sublevel, in P sublevel, in which orbital that electron is present, means in which direction that electronic cloud was arranged, that information we require. So for that, we have third important quantum number, that is nothing but magnetic quantum number. So now third one, magnetic quantum number. So here it is magnetic quantum number. It was represented by M. So now here it gives an idea about the orientation of the electronic cloud. Orientation of electronic cloud in space. So that is what we call as magnetic quantum number. Means the quantum number which gives an idea about the orientation of the electronic cloud is known as magnetic quantum number, and that was introduced by Landé and represented by M. And now if you observe the values here, values of M depends on L. Depends on that of L. See now the relation. L value depends on M, whereas M value depends on L. So these three are internally related. And here, if you observe the total values of M for a given L value. So here, for a given L value, values of M or number of values of number of values of m, that is nothing but 2l plus 1. And one more, each m value represent one orbital on one orientation. So this number of values of m is nothing but number of orientations. Number of orientations. And each orientation is nothing but one orbital. So it is nothing but number of orbitals in a sublevel. So that is nothing but 2l plus 1. So like this, first we have to find out how many values are possible for m. And after that, these 2l plus m values, they are from minus L to 0 to plus L. Minus L to 0 to plus L. So that is the range of m values, minus L to plus L. So now this concept, if you apply for L equal to 0, L equal to 1, L equal to 2, like that. So now suppose if L equal to 0. So if L equal to 0, that is nothing but S sublevel, and in this number of orientation, as per the formula 2L plus 1, means we have only one orientation, means one orbital, and the value minus L to plus L means here m will be 0. So here one thing that is very clear, for any S electron, both L and m are 0. That information you have to remember. And if L equal to 1, that is P sublevel, and in this we have three orientations, means m is having minus 1, 0 and plus 1. So minus 1 is one orientation, 0 is another orientation, plus 1 is another. Now they are nothing but Px, Py and Pz. Generally 0 is for Pz. If it is Px, it will be Py. If it is Py, it will be Px. That is okay. But m value 0, that we have assigned for Pz. Okay. And similarly, if L equal to 2, then that is nothing but D sublevel, and in this the values, 5 values, 2L plus 1 as per that formula, means minus 2, minus 1, 0, plus 1 and plus 2. And here also 0 is for dz square. So like that, here we have m values which indicates regarding the orientation or the orbital in a sub level. So like that, with the help of n value, we are getting an idea about the main energy level. With the help of L value, we are getting an idea about the sub energy level. With the help of m value, we are getting the orbital. So now, suppose for this here, if m equal to 0. So what does it mean? L equal to 1 means P, m equal to 0 means Pz, and it is third. Means the electron what we require, that is arranging along the z-axis of P sublevel in third orbit. That is a very clear information regarding the electron. So now, if you observe these three values, that is n, l, m, if you are writing those values, simply we can say that writing of quantum numbers is nothing but addressing of the electron, as like our own address. Yes, electron is also having its address in an atom. So now, writing of the quantum numbers is nothing but addressing of the electron. And these three are internally related. And one more point, the values of these three quantum numbers we can determine with the help of Schrodinger wave equation. Okay, and the last one, that is spin quantum number. Fourth one, that is spin quantum number. It is independent. It is not going to interrelated with any one of these three, because the spin quantum number depends upon only the spin of the electron. Spin is two types, means clockwise and anti-clockwise. So now here this quantum number gives an idea about spin of the electron. Means in which direction the electron is having the spin. Of course, it was introduced by Ulenbeck and Gauss-Sweet and represented by the letter S. Okay, now if you observe these values, here it is having two values, minus 1 by 2 and plus 1 by 2. It is for anti-clockwise direction and it is for clockwise. Anti-clock and clockwise. So like that it is having only two values, either plus of or minus of. So this is the fourth quantum number. So like this we have mainly four quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Now as far as the questions what we are going to expect here, especially one important model, that is correct set or wrong set. For that purpose, once again I am mentioning the conditions. The first condition is no electron will have n equal to as 0. Means here n should not be equal to 0. This is one condition. And another one, what is the maximum value of L? That is n minus 1. 0 to n minus 1. Means for any electron, L should not be equal to n. It is always less than n. Always less than n. This is another condition. And third one, if you observe the values of m, it should be between minus L to plus L only. So by having these three in your mind, we can identify whether the given set is correct or not. So that is regarding the information related to quantum numbers. So be clear about all these points. Definitely you are able to answer the questions related to this concept. Okay, so try to use this in view of those objective examinations and you will get the model bits in next class. Okay, thank you.